So yeah, our next speaker is Adam Hawkins. He's currently living in Bangalore. He's working in Saltside. He's part of the site reliability engineering team and basically manages it and trains the new people who join that team. He's a traveler and a trance music lover. Uh, the talk of the topic is shipping code at Saltside 2 years on Docker as it's basically the experience, the journey of taking Docker to production. Applause of Adam.
Thank you for the introduction. You got the most important part right, which was the trans addict. Yeah, so this talk is really a kind of 2-year retrospective on what it was like starting with Docker just after 1.0, taking it all the way to production, and where we are now, and about the workflows and the way that we use container technologies at Saltside. So before we get started, I have a question for all of you in the audience. How many of you have heard of Docker? Okay, so that's 99%, right? How many of you have used Docker in the development? Okay, how many of you have deployed Docker to production? The hands start to slowly go down and down and down, right? So for those of you who have actually deployed Docker to production, are you using something like Kubernetes, ECS, Mesos, anything like this, or are you using homegrown things? So raise your hand if you're using some off-the-shelf solution to deploy to production. Okay, like 2 or 3 hands, right? If you're using your own homegrown thing, raise your hand. I don't see my team members raising their hand, right? So I work for Saltside. Saltside is actually founded in Sweden. I was working there, and just about 1.5 years ago, we opened up an office here in Bangalore. I joined Saltside in 2013. Been in Bangalore since 2000 and just over 1.5 years now. Actually, was the first person in the Bangalore office. Now I lead the SRE team at Saltside, where we do infrastructure management, like production operations, developer tooling, pipelines, all that sort of stuff. And you can find me on Twitter or check my blog for more information. And I would really appreciate it from all of you if you have some questions about the talk, to just approach me in the hallway or whatever if you have questions about anything that I say, or maybe any issues or concerns that you're facing or you want to know more about. And also don't hesitate to find my team members also who can probably help you out. So the really goal for this talk is to help you learn from our mistakes, right? So we'll start off by talking about a little bit about the company, how we work, our production environment, what we do as a business, and why we are that way, and then where we're going to go, right? So this is a retrospective, so it's about the past, the present, and more focused on the future. So Saltside is a product company, right? So as we'll see in the coming slides, what we do, the easiest way to sum it up is we make Quicker, but for other countries, right? I'm guessing most people in the audience here are familiar with Quicker, but we have one product and one code base, okay? So what you see on the screen here is a screenshot of our web application landing page for our classified sites, right? The important thing to take away is that these all pretty much look the same, minus there's a different map, there's some Bangla there. It's a bit different, but in general, it's the same thing. So what this means is that we have one product, one code base, but we operate in these 4 different markets, right? So Bangladesh, Ghana, Sri Lanka, and Nigeria. And this is why I say this makes Saltside a curious case. Because how many of you are dealing with one production environment? Only 2 people have production responsibilities here? That's kind of surprising. But what's strange for us is we have 4 production environments, right? These are unique, right? So we have 4 production environments, 4 staging environments, 4 QA environments, 4 UAT. It's just a matrix, right? It's multiplied. And that creates some interesting infrastructure requirements, right? First off, everything has to be done n number of times from the beginning, right? So you have to think about automation in a different way. If you need to do it once, you're going to have to do it at least 3 more times, right? And as the business grows, they probably want to launch in new markets. So from the infrastructure side, from the technical side, we have to be able to react and make that happen. So this is a rough organizational map of us geographically. We have one team here, product development team in Bangalore, another product development team in Gothenburg in Sweden, a management office in Dubai. We have the 2 markets in Africa and 2 in Asia. And most importantly, we have those 2 AWS regions pointed out in black, EU West 1 and AP Southeast 1, right? Infrastructures are located geographically closest to the markets that are going to serve them. So for Bangladesh and ICMIN, we serve them out of AP Southeast 1, and for the African markets, we serve them out of Europe. So the company is actually like 300, 400 something employees, but really only about 50 or so people in product development and something like 30 engineers. So 1 product, 4 markets, 2 AWS regions, and we operate a distributed system. Microservices is kind of the new hotness word that everybody talks about these days, but I don't really consider our application microservices. The reason is because our services are interdependent. They cannot exist without the help of another one. So we have 15 plus services written in 5 different production languages: Node, Go, Java, Python, and I say Java, and we have something like 300 containers that make up our overall production environment, right? So this is not, say, per 1 market, but this is if you aggregate across all of those things. From the operations perspective, we're looking at 300 unique containers. And organizationally, we're a mix of cross-functional teams, and we have 4 people in the SRE team. So myself, 2 people here in Bangalore, and 1 person in Sweden. And obviously, we're hiring like everybody else. So if this is interesting to you, you can come talk to me. So to set the stage for this, we have to go back, about 2.5 years, quite some time, back in Q3 2014. And what happened was the company was founded in 2011, and over the course of 3 years, they acquired a significant amount of technical debt. Technical debt to the point that it was no longer capable, the engineering team was no longer capable of really doing anything besides maintaining what was there. And we made the decision that we would actually rewrite the entire product and the infrastructure from scratch. And given this as sort of an advice talk, the one thing you should take away from this is that you should never, 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 never rewrite your entire world from scratch. It can be fun, but usually it's the wrong business decision. But the reason why we did that was because technical debt, and we also had a bunch of new hires. We actually kind of quasi-acquired another team. So we had all of a sudden like 25% increase in the engineering size. We had Android developers, we had iOS developers. The business team wanted to do something differently. It was sort of a confluence of all these decisions. And at that time, we were actually running all of the markets on one production environment, and we needed to split out for isolation purposes. And at this time, we only had, I think, 2 or 3 different services. So we had the classic Rails gigantic monolith. If anybody has ever experienced that, you know the pain. And I was one of the leads of one of the teams, the backend team. So kind of set the tone for how we would architect and go forward. And just a couple months before doing this, Docker 1.0 was released. So figured, let's run with this Docker thing and see what happens. So why did we actually choose Docker back then? And we're here at this DevOps conference, right? So this is about the intersection of all these different sort of business activities, development, operations. We're all trying to achieve whatever the business goals are that we have. And in order to do that, we have to put the engineers or the people who can actually do those things in a position where they're not say, hampered by some technical requirements that prevent them from doing the best work that they can do to build whatever things that they need to do, right? And given that at the time we were a team of maybe 9 or 10 people in the backend team, and all of us had very different language backgrounds, right? There was no common language. It's like, okay, I know Ruby, he knows Go, he does Node, there's some Python. There's not really a high intersection, right? So what we wanted to do was say, look, do whatever you want, use whatever you want, and let's standardize our infrastructure on something so that you can do that. Hence, we ended up with Docker. So build your image, we can run an image, and off we go. And we wanted development and production parity as close as possible, right? People talk about Docker and, oh, you can be one-to-one with production. Yeah, that never actually really happens. Maybe you're using the same image, but you're really never using the same infrastructure. Like, how many of you have a real copy of your production environment on your local machine to do your development? No, I never heard of that, right? But what this enabled us to do was actually also standardize our workflows across the different applications, the different services, the different code bases. So as I wrote here, the development environment is basically Docker, make, Docker Compose, and a few other things. Because now you don't need, say, host level things. If I'm working on project A that requires, say, a whole Ruby stack or Python stack, whatever, and I go to project B, which is Go and all this other stuff, I don't need anything, right? As long as I have Docker and a few other things installed, it's a pretty seamless transition workflow-wise, right? And I didn't put it on here because I didn't want it to be recorded, but at the time, Docker was really, really cool. And I think, at least from my team and the people that I was working with, and the general census was like, this is the new thing, right? And over the past 2 years, what we've really seen is that containers and Docker and all of these things have really just taken over the whole world. So we have to rewind the clock a little bit to come back to what the ecosystem was like in 2014, right? Earlier, you saw Ian deploy an application in, 5 minutes on Kubernetes. Yeah, and in 2014, the answer to those things is basically, lol, no. You don't really have anything, right? So Mesos, maybe Kubernetes was around back then, I don't necessarily know, but the state of these orchestration things was like, oh, this is basically some open source project on GitHub. Maybe it works, maybe it doesn't, but most likely you don't want to bet the future of your business on these essentially kind of random open source repositories. Now we take things like the official Docker images for granted. They weren't there, right? So we had our own registry where we build these base images and use these things. Docker machine, also not even there, right? And most importantly, establish best practices. Nope, you got nothing, right? So in this way, you're really just kind of out on the edge, right? We're like, okay, let's go with Docker, and now what the hell do we actually do with this, right? Because at that time, everybody was focused on using Docker in development. But now, if you look what's happening today, and also in the talks that are scheduled for this conference, it's about how can we go to production, right? If you joined the sort of Docker front back, a couple years ago, it was, okay, I need to figure out how to do development, and I need to figure out how to do production. The development part is kind of sorted out now. Now most of us are focusing on production. But times really have changed over the past 2 years, right? So what we decided to do facing all this stuff was that we had to roll our own. There was really no other option to do this, right? So there's two factors that really contributed to this decision. One, Saltside is a curious case, okay? We need to have n number of markets times n number of environments. That needs to be automated. They need to be scaled independently, right? Maybe one market, let's take Sri Lanka, for example. Much smaller population. Let's take Nigeria, for example. There's 2 extra zeros on the size of their population. So the traffic we see across the different markets is very different, right? So given that we have these 15 different services, we also need to be able to scale them vertically and horizontally depending on the market and the environment, right? So we built our own thing. And it was basically sort of, if you've seen Docker Compose now, it was sort of that approach. We have a config file that says, okay, this is the image, this is the command, these are the scales for the different markets, these are the environments, and we pipe that off to this Ruby program we call Apollo, and what that does is generate a ton of dynamic CloudFormation templates. And then off you go, right? That will create all of the machines and this sort of stuff. And one EC2 instance per, or one Docker container per instance, right? Reason being is that is basically the easiest thing that could possibly work, right? And all of the containers that have exposed ports are behind a load balancer, right? We do service discovery via DNS, and we actually run HA proxy on each individual instance to handle the zero downtime switchover between one running container and the other when we do a deploy. And we have just a cron job that's running on each machine that's pulling some file on S3 that says, okay, this is the tag, this is the image and tag that should be running, and if it changes, it does whatever to bring up the new container. And, I mean, it's worked, basically, since, 2 years. But I will say it's taken 2 years to get it to a point where it can work really well, right? In the beginning, it was quite a difficult thing. But here you can see sort of an example of what it looks like to actually deploy code right now, right? So we probably have something like, I don't know, 30 deploys a day across the various services. So we have the CLI, you tell it to deploy, that changes the tag. And you can do this Apollo update command, which will change the scales or sort of the topology of the infrastructure. So 2 years later, it works. It actually works well enough to the fact that people have forgotten that it used to be broke. That now deploys basically work all the time, right? Unless there's some user error, like they ship an image that contains, say a command that doesn't exist inside the image, or some other like misconfiguration on the on that side. But one container per EC2 instance is actually really, really expensive, especially when you're dealing with 300 containers. I mean, I think right now our total AWS footprint across all the different environments and use cases, something like 500 instances. But we are in sort of the simplest thing that could possibly work. And that got us to where we needed to go, but it doesn't take us to where we need to go next, right? So if you look at the current generation of tools, what you see is things like blue-green deploys, different rollout strategies. You can do things like canary deploys. The things that are happening right now with Mesos and some of the other frameworks on top of that are so much more evolved and powerful than anything like 3 people could build just trying to get some containers running, right? And deploys are async. So we don't actually know if they succeeded or not. They usually work, but if they didn't, you have to SSH into all the machines and figure, okay, here's the logs and all the stuff that went wrong. And time to bootstrap new services is measured in days. Now, why is it measured in days? Well, it doesn't really happen very often, and CloudFormation takes time, right? If that fails, you have to destroy it, repeat again. I mean, if you've worked with CloudFormation, that can really be a tedious process. It's not hard, it just takes a lot of time. And also the time to actually train new employees takes forever, basically, right? Because one, we have our like small amount of internal documentation, and there's the inbuilt cultural knowledge and things like that, but you can't just say, Google Apollo. And people actually do that, and we get kind of screwed because AWS has their own internal deploy tool called Apollo, which is, of course, much better than ours. But we had some people who joined the company, and in the interview, I talked to them and tell them we have this tool, and this is what it does. And they Google it. And then they come in, they're like, oh, we're going to do all this cool stuff. I found out about it. It's from AWS. I'm like, yeah, that's not even close to our thing. Unfortunate naming. But realistically, the tool is sunset. It's no longer maintained, right? If we have a bug in it, we fix it. But the approach is no longer valid, right? Say, for example, if we need to, say, create a new market. We don't even know if that works anymore because we haven't had to do that since the rewrite. How many of you have a staging environment? Raise your hand. Okay, how many of you feel good knowing, like feel good that you have a staging environment that you can test your stuff out on. Okay, so maybe only a few of you are actually getting value from your staging environment. Given that we have one EC2 instance per, or one container per instance, it actually became cost ineffective for us to have a staging environment. Yeah, one person is now like, oh my God, like, yes, welcome, right? So we have to do something differently. So we kind of punted on this whole problem when we decided to write our own thing because we don't know. It's not really so important to us as it's not a key like value add to our business to just go off and do this thing. But now we have Kubernetes, we have Mesos, we have like ECS, we have Rancher, we have all of these things. I mean, there's a sort of a explosion and proliferation of orchestration tools and production deployment options. So right now we're actually doing a POC of migrating all of our infrastructure to Kubernetes. And given that we already have all the images, all we need to do is write all of the deployment files, all the configuration things, and hit go, right? I mean, we're container native. It doesn't really matter what runs our containers as long as they're there and they can network and talk to each other. So there's two primary goals here. One is to decrease cost. The other one is to actually, well, let's use a tool that actually works, right? So, and this Kubernetes or all of these other things can actually say monitor your deploys. They know if they failed or not, right? It doesn't take a manual interaction. And I think the final 2 points are even more interesting to me now in retrospective is, it might be cool and nice to hack on your own thing and make these sort of tools, right? But at the end of the day, if there's only one person or two people in the organization that actually know how to use that, those two people become bottlenecks for pretty much everything, right? It's a very hard thing to unclog. There's no blog posts you can point to. There's no videos. There's no tutorials, right? Everything has to be done by those few people who know it, right? And most importantly, right, is giving all of the engineers the tools they need to increase their velocity, right? The previous slide I talked about time to bootstrap new services maybe from days, right? If we can go to a matter of minutes, that's orders of magnitude, right? And making that accessible to everybody increases the entire organizational velocity. So that was a bit about production. Now I want to talk a little bit about the development side. And earlier I mentioned that unfortunately, due to cost reasons, we don't get to have a staging environment. So that's not really feasible in the real world, so you have to come up with an alternate solution, right? So what we did was kind of look at this question, right? We have 15 plus services. There's 3 or 4 teams. They're all actively developing n number of new stories or working on n number of bugs. And there's a QA team who's supposed to check everything and make sure it's all good. So we can't do it using our internal tool, and we need to answer this question. So how do we do that? So we have a few organizational contention points here. Is that one, even if it weren't too expensive, Apollo as a tool does not support like n number of environments. It's all kind of hard-coded based off of some things, and those assumptions are made in the infrastructure. And the client developers, when I talk about clients, I mean the Android engineers, iOS engineers, the web people working on the web application, they all depend on some API. And there's definitely better development practices to follow, but at the end of the day, they are dependent on an entire up and running platform to do their work, okay? And a QA needs to be able to easily sort of switch between n number of things that they're trying to look at, right? They can't spend hours saying, okay, I need to bootstrap a new environment and do these sort of things. And again, if we don't have staging, how do the engineers do some sort of experiments, right? If they're building a new service or they're trying to interact with another one, where do they do that, right? And how does we save everybody in the company from trying to manage all of these different services, right? I mean, probably all of us have joined companies where we could maybe spend 2 weeks actually bootstrapping our environment for the first time. And Saltside as a company is actually just growing, like there's people joining every week. It's not really feasible to have every single person spending 2 weeks just setting up stuff. So they came up with this idea called Sandbox. And the way that this is actually the first time I'm talking about it publicly, but it's really fun to share with all of you. Sort of infinite environments built on top of Docker Compose and Docker Machine. So given that we use Docker, we have all these images, right? It doesn't matter how they're actually running. As long as they're connected, we can create all the containers and create a fully functioning version of the product. Now, combine that with Docker Compose and Docker Machine, now any developer can launch a new environment, run it on EC2, and they can create Sandbox 1, Sandbox 2, Sandbox 3, Sandbox 4, n number of things that they want, right? And since it's built on top of Docker Compose, we get all of this nice stuff that people want to do when they're experimenting and trying to figure out like, oh man, it's broke, what do I do? It's not working. Well, you just run Sandbox logs. That's built on top of Docker Compose, so you just get this nice log stream, right? We have some like additions to the Sandbox command, so you can use repository names instead of Docker Compose service names, so you could do things like this. But most importantly, what this does is say, start me out on a fresh environment that mirrors production. So the first command you see there is create, which actually creates this EC2 instance. The next one is sync, which looks at the images and their tags that are currently deployed to production and writes that to some configuration file. So then when you say sandbox reset, that starts up all of the same images that are used in production. So right away, you have something functioning. And like I said, you can get logs. And you can add and manipulate tags, right? So let's say that a developer is working on a feature A, and they push a new image and for, say, repository B. I can say sandbox tag foo service and then bar. That will change it, so I can experiment with different combinations of these things in an isolated fashion, right? But it's also exposed to everyone in the company, right? Each sandbox actually has its own ngrok container running, which gives each one its own URL. So say I have a sandbox, I can give it off to my coworker. They can share their one with me, right? We can all collaborate on these sort of different pre-production stages. And you can do this sandbox dev, which is sort of a curious case to me. But what this allows you to do is actually do a Docker build locally, and then use that image for all of the containers in the sandbox. So if you're feeling like really cowboy, what you can do is just check out the different repositories, run sandbox dev foo, and then that will start building locally. This has actually kind of created some problems, because when we use random local code, it may or may not be tested, right? And then, okay, so you have one service. Maybe it's not so much of a big deal. But if you use that approach for, 2, 3, 4, 5 services, then, who knows, right? So requires some discipline, but at the end of the day, what we have is actually infinite environments per topic branches, which is pretty cool. So all of this, this has been really a 2.5-year journey for myself and my team and pretty much everybody in the company. So this is what I want to share with you as a means to help you make a more informed decision if you do decide to, say, put Docker in production, right? So first up is don't even bother with trying to roll your own. I don't think that there's probably any organization that really now needs to roll their own orchestration or deployment system. Like as we saw with Kubernetes, it's pretty much flexible enough, right? Like for us, if we have to deploy to n number of markets, we just write a loop that does the deploy command to different environments instead of trying to codify at infrastructure level, right? So pick one of those and just go. I guarantee you it will be fine enough. But there is one other thing to consider, is you have to check where you are on this sort of inflection curve of value, okay? If you only have one application, and maybe it only has one process, right? One other thing that happened as a course of this sort of Docker and service-oriented thing is stop thinking in terms of applications and start thinking in terms of processes, okay? Maybe one service has 3 or 4 processes, okay? We have code bases that have, or I think our biggest service has 4 discrete processes that are deployed. There's a web server for HTTP and JSON API. There's an internal thrift server that communicates with other things. There's a background job processing queue, and there's another container that runs a web admin for that job processing queue. So it's not just about applications, right? It's about processes and how these processes communicate, right? And what are the roles of the processes? What load will those processes see? How can I scale and interact with these things? So that's not written on here, but that's one of the subtle sort of assumptions in thinking. So if you only have, say, one application that is just a one web server, you're not going to really get so much value out of doing Docker stuff, especially if you try to get going with Kubernetes or any of these orchestration tools, right? That's why I mentioned this sort of inflection curve of value. If you only have 2 applications, right? If you have 10, things change. If you have 100, oh, okay, you're in a whole different ballgame, right? When we consider the different production infrastructures and deployment strategies, we have to think in these orders of magnitude. And if you look at Kubernetes, Mesos, and DCOS, what these are really about is tools for building distributed systems. An application with only one process is not a distributed system. So just be careful. You don't want to choose the wrong tool or jump into sort of a bigger area too early. And now use Docker Compose for development stuff, because you can use that later to maybe create something like the sandbox thing I mentioned. And really having our whole workflow containerized has made development pretty straightforward. We don't have to worry about anything on CI because all those machines need to have is Docker make, Docker Compose. So the whole stack of things that we have is very minimal, and we use that through all the different sort of phases of the software development process. And sort of a plug for Google, but right now, if you just want to get some production infrastructure, just use Google Container Engine. Just try it. Like, don't even bother setting up anything else, right? Because the question you have to answer is, what is actually important to what I'm trying to achieve, okay? And if the goal is to actually deploy something, who cares where the infrastructure is, unless you have some very specific requirement? Like, is it more important to actually get whatever thing I need running, or do I want to spend time mucking around, creating auto-scaling groups, security groups, and blah, 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 right? So if you have the option, just seriously just choose Google Container Engine. Don't even waste your time. And I highly, highly recommend that you do some way to sort of package up your whole application as something you can hand off to some other person in your team, right? This might be like a Vagrant image, maybe like a baked AMI that you can start or something, right? But as your whole system grows, becomes bigger and more interconnected, more distributed, whatever, it's no longer possible to just tell somebody to set it up, right? QA, maybe even some product owner. They don't know the technical stuff. They just say, I need to click this and see if it's working the way I expect it to, right? So you have to minimize the barrier to entry there. And you can, there's containers and Docker, all this stuff is a great way to do that. But just decide some way to do that and bake it into your process. We've made an unfortunate mistake that given that the scale of our system was much bigger than we expected, we didn't actually have the budget for as much logging and monitoring as we wanted to. So when you're considering maybe building up this whole new infrastructure, think about how much it might cost. We made one mistake by packaging up this Apollo as actually a command line. Instead, create APIs instead of CLIs, right? So you can have a CLI that talks to the API, but now you can move that interaction off the command line and say into chat or into any other medium, right? So Docker is also a pretty nice way to distribute internal tools. Like this Apollo CLI was actually a Ruby application, but nobody had Ruby installed. So we just build a Docker image, create a little shell script that does the Docker run, blah, 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 and off we go. So use any language you want. Containerize as many things as possible. You will see a bigger organizational and technical benefit if you go as Docker native or container native as possible. You're not going to get the same benefit if you just dump a Docker file into some project and then 10 stages down the pipeline you eventually do Docker build. Recommend one Docker file per project. This is something that I have observed. Like if your application contains multiple processes, package up everything in one Docker file and then use that with different commands instead of creating n number of different Docker files and hence different Docker images. And don't even waste your time making your own base images. That is just really a waste of time, right? We did that for a year and a half and that sucked. And it's even worse now if you were to do that yourself, because now the official images have like security scanning and all of this stuff and they're shared. So odds are many people have access to those common images. And most importantly is adjust muddy. That you always have to be willing and capable to adjust and adapt, right? If we point back to earlier in the talk, one of the big reasons why we went Docker was we needed to be able to adjust to current requirements and future requirements, right? We had just in the last 6 months, we had a whole bunch of people join the engineering team that had no experience using any of the technologies or languages that we use right now. We can't just say, oh, you need to learn language Y. Instead, they actually got to use Java and do whatever they needed to do to achieve the goals of their team and thus the goals of the business. So in the technical decisions we make and the organizational decisions we make, remember to stay flexible because eventually you will always have to adjust. And with that, I say thank you. I open the floor to questions. Got one guy back there.
When your developers are using Docker Compose and trying out during the development on their own local machine, so when you take that to a Kubernetes production environment, how do you translate all that Docker Compose into Kubernetes artifacts? Are there any people who are like doing manual translation, or is there any tool you use or anything like that?
Well, that's a very good question. And this is one of the things that we're trying to answer in our POC. But the Docker Compose use and the use case we have for that is really different than what we would do in production. But that being said, we are investigating a way to programmatically take the Docker Compose stuff to generate the Kubernetes configuration for our POC. And based off of the answers we find during this sort of spike, then I can probably have a better answer to your question.
Yeah, hello, Gaurav this side. So have you guys also tried Docker UCP? Like you mentioned 3 resource manager, like Kubernetes or like Mesos or something, but like there is some inherent capabilities like Docker Compose. It really gives a very, very big tool to the developer, so you can package your complete applications or complete stack, and which is not even possible to implement or to use in these tools, which are not Docker native, right? But in terms of Docker UCP, they have some concept or like the new versions of Docker. So what's your take on the same?
Yes. So on that slide, on the takeaways, I decided to actually omit UCP in Docker Data Center because we actually did an internal spike on it, and it turned out that, in my opinion, it's just simply kind of crap. It doesn't support the new versions of Docker. When I talked to their support, they didn't actually have anybody who was using it in a production environment. They also could not handle different nodes in different availability zones. So at the time, as of now, I recommend that nobody really get involved with UCP or Docker Data Center for production use. This might change in version 2. When that will come, I don't know. But right now, for production, I advise to stay away. As for your other question about Docker Compose and config and some of the other tools, we actually did a spike on a Mesos sort of POC, and sure, we didn't have like Docker Compose, but you can create your whole config file for every single part of your thing. So we actually ended up with like God knows, like a 2,000 line JSON file for everything. But those tools they all sort of support the exact same functionality, but in different things. But it is true that they're not actually using like Docker commands. So if that's one of the requirements that you have, then you're basically stuck with something like Docker Swarm or just a big Docker host.
Okay, that's fine. And one more thing which you mentioned in your presentations, like one way people are normally looking Docker is as a packaging way to ship the product and using the capabilities of orchestration. And one thing you mentioned regarding the tooling. So in a tooling, like for my laptop or some laptop, only Docker required. If I need to compile my artifact, then I need a compiled Docker which contains all the dependencies or all the software which required to compile my code, and then I need a Git just, and then I need to create an artifact, right?
Right.
So there is a major challenge here is in a production environment or in any environment. Say you are using some Docker image, official Docker image, and you are compiling, say, your Java code or some code.
Right.
And it generates some artifacts or some data which is on host system on which the Docker daemon is running. So there is a practical challenge, which is the permissions problem. Like your Docker image is running as in a root.
Correct.
And you log in that systems because there is maybe a robot or pipeline.
Correct.
And maybe that pipeline is running as a S user.
Yes.
So the artifact it generate on the local systems is normally root because that's the
correct.
So how you saw there is one way, that is Gosu. That's one way, right? People are using. But is any better way, or how we can, because Gosu is again not a good way.
Right.
There is a lot of challenges there, definitely. So have you solved this problem or not?
I would say that I've not necessarily solved this problem like at the root, but I do have 3 solutions that work around or solve this particular issue of basically volume mount permissions when the Docker daemon is run as root. When you do a Docker run, you can patch the -u flag or the long flag --user to set the ID. So if you do -u set, subshell ID -u, you can run that container as the user that is invoking the Docker daemon. So if you have a shared volume, the things written to that volume will have the user ID of the current user and not root. That's kind of finicky. Option number 2, which works, option number 1 actually only works with local volume mounts. So if you happen to be running that against, say, a Docker Swarm or something else, it's not going to work. But if you use option 2, which is to do Docker start and then run the container, and then Docker CP for copy, that will copy an artifact or file from the container to your local system. And that will not have any permissions issues at all. But it's a little bit more complicated than doing Docker run. So you have to do Docker create, Docker start, blah, 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 Docker copy, and then Docker stop, Docker rm. Option number 3 is to sort of invert that problem by not having separate images to those different things. That's a bit more of a vague answer. But if you remove that sort of as an assumption that you need to have like these, they need to be copied onto the host or whatever, but do all of that actually with images and containers, and that problem also goes away. But option number 1 and option number 2 are the easiest things to use right now to solve that problem.
In a case of option 1, when you are running a container or an image, you need to pass a flag -u or something, right?
Yeah.
Say, but I think it will not work really. Say there is a Docker image, say for Java as an example, right?
Right.
And you are mapping your folder, and you logged into a Docker daemon machine, say as a Go or as a S user, right? And then you start the image, and you just pass your artifact, or where is your .java files, and you say please run or create my artifact, say maven1, right?
Yeah.
So if you pass any user, say you are, say, S user ID you are passing before running a container. So there is lot of permissions issues, right? Means whenever that container was created, the image was created, maybe there is no users, say S, right? So you will not run some of the things. Means you have to change lot of permissions, everything. You need to review the complete Docker file or the image, how it was created.
Not necessarily. I would be happy to show you something that will probably work for you. I actually have a blog post on the specific problem I can share with you also.
Okay, thank you.
the green shirt back there and one guy up here in the front.
Hi.
Hey.
I just wanted to know what are the steps you did to convince the business about the decision of going with Docker native, because it must have been a huge change for you, right?
Yeah.
So we are also struggling with something like that right
Yeah.
now, trying to convince the decision makers, the stakeholders,
Yeah.
showing them that this is worth it. And especially at a time when you did not have the full ecosystem of tools, when there was so much risk involved. So how did you handle that risk versus benefits? How did you show them all that?
Okay, so I have two solutions for you, two options, right? Option one, which is much more difficult, is to actually become the decision maker. Luckily, when we made the transition, I was sort of the decision maker with some sort of back and forth with the CTO, but he was more or less supportive. And really what I think what it comes down to is value throughout all phases of the software development process. And especially if you're working with multiple languages, then you have a means to standardize development workflows and any number of post-development environments, be that UAT, staging, QA, production, whatever. And at this point, how I see the future going is that if you are not paying attention to these technologies, you are going to be left behind. And at some point, it's going to happen. And I think if you can do anything to talk about the say the organizational value, because there's there's a bunch of factors. There's the organizational value, there's the business impact, and of course the technical impact, right? I think even some of the things I talked about here, by using containers, not just Docker, I mean mostly Docker when we talk about them now, is that it opens up so many other use cases that you may not have had before. Like this example of these infinite environments. It may not just be about adopting a particular technology, but focusing on a particular use case. Like what is one outcome or goal that the business wants to achieve? Find something like that and say, okay, can I use Docker or other technologies to meet that goal more efficiently or in some way better than whatever our current stack is, right? Start with small POCs, small prototypes, and follow the sort of Docker approach, which was to make devs want it, right? I mean, Docker won as a technology because devs wanted it, right? So if you can sort of spread that with your coworkers and the other engineers, then sort of organically combine with some sort of like POCs and prototypes, you can probably get some level of adoption. I think we have one more back there. I don't know how much time we have left, but
hi.
Yes.
So my question is about how do you handle production secrets in containers?
yeah. So about the secrets, again, we do the simplest thing that could possibly work, which is we put them in environment variables. We do our best to encrypt them before that, and then eventually they make it onto environment variables in the containers. No. So one of the other takeaways here that I forgot to mention is actually follow the 12-factor app principles, right? So all of the processes accept all configuration either through command line flags that default to environment variables or environment variables. So just set those on the container when you do Docker run. So the infrastructure handles some of those secret things, but admittedly, it's probably not as correct as it should be using something like Vault or some other more, use case specific secret store. Like even AWS has their own secret store now, I think, but we don't use a very robust solution there. I think we have time for maybe the one guy who's been waiting the whole time back there, and also some guy over here.
So we'll just take one question more. After that, I know this is an interesting topic, so we can maybe cover it in open space.
Yeah, and just come talk to me afterwards. As you can see, I'm a very talkative person, so just ask me a question.
All right, so we as an organization, we are looking forward to a container-based technology.
Right.
Now, right now, Docker is everywhere. And that's probably the tool. So this is a question to you. So let's say 1 year down the lane, if a new tool like Soccer comes up.
Or Rocket, or Run C, or any of these other alternate implementations right now.
Yeah. How would it be easy to adapt?
If you have taken sort of the appropriate steps in choosing some of the infrastructural decisions, then changing your container runtime may not actually be problematic. And actually, I just happened to write a blog post on this exact question. And what I said was that in probably 2 years from now or some number of years down the road, Docker will be whatever. But if you look what's happening in the orchestration tools, what they want is something that's more focused around containers, not necessarily a daemon running containers. Like Kubernetes itself is actually trying to integrate more, like quote, first party with the OCI and the various open things that have less sort of assumptions about how containers should be run. So if you do not rely on, say, Docker specific things like, say, Docker Compose or like UCP or other things that are really targeted at the Docker ecosystem, if you just think about containers and images and choose an appropriate like orchestration or deployment infrastructure, then I think it will be certainly less painful to migrate than if you were, say, using Docker Data Center backed by Docker Compose and all of these things.
Thank you, Adam. It was a great talk.
Thank you.
Thanks, Adam.